Hello everyone. In today's class, we're gonna look at an example from chapter 4 on submerged surfaces. So for this example, we have a reservoir that's used to store oil. Okay, and we were asked to find the resultant force taking place in this submerged surface. Okay, we're asked to find the resultant force and to find the depth of where the resultant force is happening. Now, we know that the resultant force happened slightly lower than the centroid, and that is called the center of pressure. So we're given the specific gravity of the oil, which we can use to find the specific weight. We're also given the gate's dimension, the base, and the height, which is used to find the moment of inertia. We're also given the angle of inclination, where the gate is placed, and we're also given the depth from the level of the surface to the centroid of the gate. So let's just label what we have. This here is HC, which is the depth from the level of the surface to the centroid of the gate, the submerged surface. This here is the angle of inclination. We already have it labeled. The dimensions is pretty clear. We don't need to label that. What we do need to find though is the HP, which is the depth of where the let me just make this dashed lines. It doesn't matter. This is HP, the depth of the fluid from the surface to where the resultant force is acting, and this is where the resultant force would happen. We also need to find, in order to find HP, we need to find first LC, and LP, which is basically the length in an inclined angle from the point of the centroid to the level of the surface. That's LC. And LP is the inclined length from the point of pressure to the top of the surface. So that's LP. Okay, so let's go ahead and start. To start off, the resultant force equals specific weight of oil times HC times A. Now we know A, since the submerged surface is a rectangle gate, therefore the area of a rectangle gate is width times length. Okay, which the dimensions are given. Therefore, it'll be 4 feet times 2 feet. Make sure you keep account of the units. 8 feet. The specific weight, we know that SG equals specific weight of a substance over the specific weight of water. Therefore, specific weight of oil will equal to 0.91, which is given, times the specific weight of water, which is 62.4 pounds per feet cube. That's for US units. If it's SI units, it is 9.81 kilonewtons meter cube. That's if it's SI. But since we're not working with SI, we'll use the 62.4 pounds per feet cube. Okay, so now we have all the givens needed for the resultant force. Therefore, FR equals 2,071 pounds. Okay, now the second step is to find where the resultant force is happening. In order to do that, as I said earlier, we need to find the inclined length from the centroid to the level of the surface. In order to do that, we'll use HC. So we have HC here, which is the depth. It was given to be 5 feet. The depth from the level of the fluid to the centroid, and the inclined length from the centroid to the level of the surface, that's LC, which we need to find. And the angle of inclination here is the same as the angle of inclination here, which is given to be 60. Therefore, to find LC, we'll say sine 60 equals opposite over hypotenuse, which is 5 over LC. Therefore, LC equals sine 60. 5 over sine 60. LC equals 5.75 feet. Now we can use LC to find LP, which is what we really want, in order to find HP. Okay, so using this equation, LP equals LC plus moment of inertia over LCA. Now we have LC, we have A. The unknown is the moment of inertia, and the moment of inertia depends on the shape. Since we're working with a rectangle, therefore moment of inertia will equal to BH cubed over 12. Now it's very important not to mix the base with the height. I know it's easy to do so, but since the height is cubed, it will affect the calculations. So if you pay attention, the height is usually going vertically in an inclined angle, and the base is going horizontally. So the height is basically the length vertically. I know it's inclined, but it's still vertically. So the height is 2 feet and the base is 4. Okay. Moment of inertia will equal to 4 times 2 cubed over 12. That will equal 2.66 feet to the power of 4. Now we have the moment of inertia. We can plug that in here. Plug in our givens. We calculated the area before. LC. Therefore, we'll get LP equal 5.81 feet. Okay. Now going back here, can do the same thing again. Use LP with the angle of inclination to find HP. So it's similar to what we did here, except that the HP is unknown and the LP is known. So we'll do that again. That's your LP. 5.81 feet. My drawing is not the best, but hey, we'll work with it. It's very important to label your givens and unknowns. It makes it easier to solve. HP. Therefore, sine 60 equals, this looks like a 68. Let me just fix that. Sine 60 equals opposite, which is HP over hypotenuse, 5.81. Therefore, HP equals 5.81 times sine 60. That will give us 5.03 feet. Now, this is the depth from, so if we look at it like this, let me just go back. HP is the depth from the level of the fluid to the point of pressure. It's the vertical depth, right? But LP is the location of the center of pressure. So sorry for the misunderstanding. This here, we're not looking for the depth of the pressure of where it's happening, rather the location of center of pressure, which is LP. So this here should be the location, the center of pressure, this here. HP is not required. Okay, that's it for this example. See you in the next one.